Yeah, so today I got a new AirPod Max, and I think the microphone is really good, and the sound I recorded will be much clearer than my previous videos. And yeah, so today I'm gonna solve a hackering problem on this live stream, and I have uh, not much idea about doubling linked list, but in previous videos we have solved linked list problems and we could solve many of them. And yeah, today we are going to solve a doubly linked list. So as far as I know, doubly link has yeah, doubly link linked list has a node, has a node or many nodes that has some specific characteristics. It has data in it, and it has the address to the previous node and the address to the next node. Yeah. So first, I'm gonna go and close the door, and yeah. All right. So as always, make it full screen, read the problem, giving the pointer to the head. Okay, I'm gonna increase the brightness a little bit. And I also bought this glass which blocks the Blu-ray. I don't know. Let me see. Okay. Anyway, um, giving the pointer to the head node of doubly linked list, reverse order of the nodes in place. That is, changed next node and the previous node of the nodes to that direction. When linked list is reversed, return a reference to the head node of the linked list. Okay, so what I'm thinking is start from here, right? So I'm gonna give an example. Say if one is linked to 2 and 2 is linked to 3 and 3 is linked to oh no, this is not how you represent a doubly linked. Okay, so you have this and this 3, 4, 5, and this will take to null. 5, 4 has okay. So what I'm thinking is when we go here, oh no, when we first here, what we need to do is this should point to null. Next should be a null. This next should be a null instead of 2. And the 2's next should be so when we get here, what is if okay, let me try that maybe current node, let me try this equals head and while current node. Well, there is current node, then current node that next equals current node dot okay, current node equals current node dot next. We need a temp here, okay? So maybe a temp here. Okay, let temp equals current node dot next. And then what we want to do is current node next equals current node previous, and hmm, we need more than we need temp two. Okay, temp one, temp. We need two temps. Okay, two temporary variables. Maybe temp two. I'm gonna call this temp two. There will be current node that next. Okay, we already have the current node that next. So okay, it doesn't matter. We already have the current node that next. So we are good. So what we want to do is current node dot previous equals current node, oh no, not current node next, it will be temp, and current node equals temp, and then what we want to return is while dot next. Okay, do you want to do that? No. Yeah, let's current node, which will be null. Okay, we can't have a null current node, so what we want is maybe let temp up here, let temp, and instead of this, what we want to do is temp equals this thing, and we want to return this temp and see if we achieved it. Wrong answer. What we got? My output is nothing. Okay, current node. So instead of current dot next, temp dot next equals dot next. Okay, now this should work. What we got? One. We got one. Why? Because we have this, right? But we don't have a temp. Okay, current node dot next will be the previous one, and then the previous one will be the next. Okay. Okay, I'm gonna say counter, let counter equals 0, and counter plus plus, and console log the counter down here, console log the counter, and see if okay, that means we are going through just once, right? We are going through the process just once. I really hate the hissing sounds the computer is making, the laptop is making because I don't know because there's a bunch of stuff going on. Okay, so instead of 10, we instead of 10, what if we return head? Oh, previous node. Okay, prev. This didn't make any change. Okay, so what we did was we assigned the current node and the counter. Okay, let temp equals current node, which will be first it will be 1, right? So current node dot preview has nothing. So it will be current node previous current node current node head and equals head. So we give the head to the current node and the temp and then counter and then we say if there is current node temp holds the current node. Okay, temp holds the current node. So temp holds instead of current node. I really want temp hold the current node.next. Okay, so temp holds the current node.next, and then current hold node.next will be the current node.previous, which is null. Okay, undefined or null, right? This is null. Okay, that's fine. And then current node dot previous becomes temp. So one dot previous becomes temp. Temp, which is 2. So 1.2 after first round, this will be something like, okay, so one has previous node, it will look like, no, wait a second. Okay, so current node dot previous is temp, which is current dot next, which is 2. So previous will be 2. And then current node dot next will be eh, will be we got 4 debug output. So that means we went through 4 times. So instead of head, what we want to do is temp. Is that what we want? Okay. If we print temp, then that is not gonna do anything. So what we want to do is current node, which will be null. Okay, which will be also null. Now the current node will, which also will be null. Okay, so we need a previous node. Previous node equals previous node equals current node equals current node. Okay, so okay, instead of this, what we want to do is and we also want to do this here, right? And then instead of this, what we want to do is previous node yes, home. We did it. Let's submit code, see if is there anything wrong. No, everything looks good. Congratulations, you solved this challenge. Would you like to challenge your friends? Okay, so we solved it. Wow, that's that was pretty simple. I'm gonna Oh, no, actually, this should go. No, my indentation. So we need to remove what? We need to remove this. We're gonna remove this. That is fine. We're gonna remove this because that is just. We're gonna remove this, and we're gonna see if there's anything we need to remove. And I wonder if we can do this. Let's see if we can do this. Because that way. Okay, let's see if we can do this. Let's see if we can do this. Okay, run. No, it's not going. It is. Yeah, that's good. Okay, so what if we did this? Can we do this? Yeah. Oh, I learned it. I was thinking we should have something like this. Yeah, this is good. So previous node, both previous node and current node will be 10. Yeah. Yep. So we did it. We solved it. We solved this problem. So do we still have time? So I really want to. Maybe we can solve one problem, or what do we do? What do we do? What are we gonna do? What are we gonna do? Insert a node at the tail of the linked list. Solve. Cycle detection, which was pretty hard. Even if its success rate is 93%, and couldn't achieve the so find merge point of two lists, inserting node into a sorted doubly linked list. Okay, so I'm gonna solve this challenge, and then yeah, this looks really easy. Okay, so the head data. Okay. Okay, in sorted list. So we have a data. So we go as usual, let current node. So what we need to do is we go through, as always, make it full screen. What we need to do is if this is the data and this is the linked list, so we need to go through the data. We want to go first, we take the first node and see if the data is no. Data is greater than this. And we want to check the next one if data is smaller than this. Okay, so if it is greater than this and then smaller than this, then we put in here, but it is not small. It is greater than current node, but it is not less than the current node next to data. and then can we do current node dot net? Okay, anyway, and then lo-fi. Okay, so next, if this is next, we go here. 2 is greater than 3, yes, and is 4 is less than 3, yes. So we put in here. So what we need to do is 2 dot next, the current node next equals the linked list we created. Okay, and then that linked list that previous will be the current node. Okay, and then that linked list dot next will be next current node dot next. Okay, we can figure that out as we go. So current node equals head, and let's node which we need to input equals new doubly linked list node, and so we want to see how this is set up, how this has been set up. Okay, so we need node data. Okay, so that is fine. So we can pass right here. So data, so that is the data. Okay, so why this should be, please, this should be right here. Why not? While current node, okay, well, current node, we have to check if current node dot next is there, right? We obviously need a time as well. We need, okay, we always need the term as well. But what else do we need? What else? What else? Split hatching. Okay, let's say current node. If current dot next, there is current node dot next. There's something called current node dot next. Then what we want to do is we need to set a new if current node that data is what if is temp equals current node dot prev. Okay, so what we want to do is I changed my mind. So what we want to do is if current node dot next that data is greater than data, then we only want to, instead of saying like if it is less than the equal, making that much of condition, making so many conditions, we can use this condition. So current node dot data is greater than data, if in that case, what we really want to do is create which is temp, huh? Okay, dot preview dot next equals node. Okay, I don't know if this will work or not, but I'm pretty sure. So current node, previous node will be the no. Current previous will be node, right? Okay, and then the current node. Mm, current node dot preview equals node. Current node dot preview equals node. Current node dot preview. Current node dot previous node equals this node. And then what else we wanted to do is current node dot preview equals this node. If that is true, then previous node, and then current node dot next. No, current node. No, okay. Node dot next. Not that next. Not that next. Equals current node dot node, and node dot preview equals temp dot preview. Okay, temp dot preview, and then current node. And then break. Else, what we want to do is current node equals current node dot next, right? Okay, so if there is no current node dot next, then current node dot next equals no, not Okay, so if current node dot it, okay, and then else if current node dot dot next, if that is true, then what we want to do is current node dot next equals node, and node dot preview equals current node, right? Else that's, and then break. Okay, let's return the head. See what we could do. Oh my god, this took too long. One is missing. Okay, what is missing? 5 is missing. So when it is 10, what we want to do is no. What is the 1? So input format. The first contains T number of test cases. Number of test case 1. Second, each of the test cases following first line is n number of elements in linked list 4, 1, 2, 3, 10. And last contains the data. Okay, so console.log immature exit. Okay, let's see if this applies. Oh no, it no 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 no. Yep, did it? No, it didn't do an immature exit. But okay, so test case this is 4. So that only got correct. We got only that part. So that means we are messing up here. So I'm gonna say console.log inside in data inserting instead of data node inserting. Okay, anyway, that's fine too, because okay, let's why does it, okay, current node dot previous node. So did we get student input data inserting? So we went inside here and somehow we couldn't connect them. Okay, So what we did was, so current node, which was 10, right? Current node, which was 10, obviously. And then what we did was 10 that previous node, 10 that previous node equals 5. Node that had containing 5. And then node containing dot next equals the node containing 10. And then node dot previous is which is 10. Not this. Just temp. And then let's try running this. What we got? You didn't get this. That's fine. So we need to maintain the previous node. Do we? Okay, I'm gonna maintain the previous node. Let's pre what? Previous node equals, okay, nothing. And when we come here, the previous node will be current node. Okay. Temp. Okay, so temp will hold. Okay, actually we don't need previous node. Okay, temp holds previous node. Okay, and then before doing that, we need to do current node dot previous node dot next equals node. Okay, next equals node, and then Okay, so we need to have a way when it has to insert in the very beginning. So what we want to do create node if create node that data is greater than data, then what we want to do is node dot next equals head crenode and crenode dot preview equals node. Okay, and head return node set. Okay, so we kind of managed. Yes, it took us around 20 minutes to figure this out. We initially had some troubles, but as of now, we solved all 8 test cases. Great job. So last thing I want to do is go to the go to the practice, problem solving, and look at my ranking. So it is currently 427, 427, 427, and we need to get down to 100, maybe 90,000 or 100, somewhere around that. All right, thank you so much for, I don't know if anyone would watch this, but yeah, thank you so much. And I have a plan in 2 hours, and okay, let's check my calendar. Okay,